Hello everyone, my name is Rajendra Thakkar. Welcome to this video for Assessment 2 for Managing Machine Learning Project Module 2. Below is one of the problems that can be solved through machine learning. Let's try to understand the opportunity for the same. The problem statement is to improve the wait time for countryside patients having the kidney stones. Currently, patients have to schedule an appointment with a doctor to interpret the x-rays and advise on the next steps. In countryside, we don't have much availability of specialized doctors, and the impacted patients might not be addressed right away due to the long wait times. Is it an attractive opportunity? Yes, this is an attractive opportunity for machine learning solutions, as there is an opportunity first to automate and second predict patients' problem to identify kidney stones, schedule the appointment, and also help doctors to prioritize the impacted patients. The problem over here is identified by feedback from the patients on the wait times, doctors' availability, and number of doctors in that area. Is there an opportunity? As mentioned earlier, yes, there is a problem, which we just called it out right now. Can machine learning help to solve it? Yes, based on the data, and we do have different models to solve for this. And does someone really care? Yes, the patients and the doctors both would be, it would help both of them. Let's go to the second point in this particular assessment is CRISP-DM business understanding. Let's try to go through the problem with the CRISP-DM business understanding template. Let's try to understand what is the problem. Is there a target user? Yes, the countryside patients. Problem, we need to triage patients who has kidney stones based on the x-rays, why it matters. We want to reduce the wait time and also address the patients right away. Current state, we have to take appointments to interpret it and advise on the next steps. And the wait time for this appointment is considerably longer. And the patients might not get the right treatment on the spot. As part of CRISP-DM, let's try to understand the success criteria. We want to, from a business point of view, we want to prioritize impacted patients, reduce the wait time, and handle the workload for the doctors. Constraints are countryside areas, limited number of doctors. Talking about some of the key metrics is outcome from a business point of view is impacted patients need to be addressed quickly. Output impacted patients having the earlier appointment and also the number of doctors required to address the number of patients. We can quote over here that we want to have the success criteria for address to address the patients within 48 business hours. What are the factors that might potentially be relevant to understand for this problem and train the model? We want to get the information of different types of kidney stones, how are they detected from the x-rays, and also different schedules for the doctor in that area. Solution validation plan, just we want to understand how this concept is going to work and how are we going to execute the experiments. We'll have a model that would take the X-ray images and determine the patients having a stone. It will use machine learning models like deep learning to predict the size of the stone and identify if it exists. We'll work on the historical model to train the data, prepare the data for modeling. This data would come from different sensors, different medical information from the doctors. We'll run the model with the training data, validation data, test data using the k-fold iterations. We'll also need to make sure that we retrain or update our model whenever the performance goes below the threshold. Here are some of the machine learning design considerations. Over here, primarily we'll go with cloud. In hospitals, we would have internet connectivity and over here we need to do the computation over the larger data set and I will have a better throughput. Learning model is online, real-time adoption and continual retraining with the new data, and prediction needs to be real time because it's online learning over here and the request is on demand. What are the potential risks in production? Do we foresee any possible issues which may arise for the proposed model like the training serving skew, latency, data drift? Yes, there is a possibility of the training serving skew, latency, and data drift models which would result in wrong or incorrect predictions, which is not acceptable in the medical industry, like ignoring the patients having a kidney stones or identifying patients not having a kidney stones because of the wrong prediction. There is a possibility of training serving skew over here where the training data and the input data which is in production is different, like low light images in the hospitals. Latency might be because of the internet blip or the low speed internet in the hospitals. At times the data drift would be based on the features that we use to identify the output are no longer responsible for determining it over the course of time. So this is an all summary for my assessment for module 2. Thank you.